In this video, we are going to explain example 1, but this time part B, whereby we are supposed to show that the cosine of alpha plus beta is equals to the cosine of alpha cosine beta minus the product of sine alpha and sine beta. And the reason why I did not rub everything else we brought on board when we are explaining example 1 and part A is because we need to use some of these identities in explaining part B. And if you look at our left-hand side of this relationship, it's talking about the cosine of alpha plus beta. And earlier on in our narration, we had expressed cosine alpha plus beta to be equals to AD. So AD is very critical here. If you go back to the diagram, AD is not expressed anywhere in our earlier, AD is already here, we have seen that, but there is no way we can get AD if we do not have to have AB minus DB. And that is why we need to talk about AD. Our AD is equals to AB minus DB. If you want to walk from A to D, it's the same as AB minus DB. You will be left with our AD. And what is our AD? AD becomes already the cosine of alpha plus beta is equals to, what is our AB? I remember we had expressed our AB in our earlier narration to be equals to cosine alpha cosine beta. It's already there. The cosine of alpha times the cosine of beta minus dB. What is dB? This is where we need to concentrate. In our earlier narration, we have not expressed dB on its own. But how do we get dB? If you revisit this original diagram, you realize that we have rectangle BCFD, and using the properties of the rectangle whereby opposite sides are equal and parallel, and therefore dB is equals to FC. So in our narration, I remember we had talked about FC. So in other words, dB is exactly equals to FC. So when we are talking about minus dB, is the same as minus FC. And what is our FC? Sine alpha sine beta. So sine minus sine alpha sine beta. And if you look at what we have brought on board finally, we have the cosine of alpha plus beta is equals to the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. And this is exactly similar to what we are supposed to show, and hence shown. And this is the other identity we are supposed to prove. And there we go. So please make sure you follow up and be very keen in this. All right?